Hi, I'm going to introduce you to GitHub Actions, whatever that is. My name is Richel Bilderbeek and this is a talk that I give at the Researcher Software Engineering Tools session we have at NBIS or SciLife Lab. And it's about GitHub Actions and I'll walk you through it. So we already start with this logo, this meme that we should automate everything. I'm a fan of that as well, and this ties in what we're gonna talk about because GitHub Actions allows you to do this. But first I will ask you what you would do if you are the only maintainer of a free and open source software GitHub repository, and you want this repository to not have stupid spelling errors, not, for example, spell checker won't detect all spelling errors, but it should be able to remove the most stupid spelling errors. You want no broken hyperlinks in your GitHub repository, and you want to also show your users the status of your repository, if there are stupid spelling errors, yes or no, or if there are broken hyperlinks, yes or no. How would you do this? And normally I would now talk to the people that are here online, but for example, one example I can imagine is that you write scripts to do this. You write a script that checks for spelling, you write a script that checks if the hyperlinks are broken, and this script, and then there's a script that calls these two, and then it creates an image on an image to be displayed on your GitHub repository with the status, or create some text in your README with the status that is coming out of this script. Sure, you can do that. This does mean you need to do everything manually, and already tying into the automate everything meme, there are probably better ways to do this. Another use case that will tie in with GitHub Actions, that can be solved with GitHub Actions, is that, let's say you're one of the maintainers of a free and open source software GitHub repository. You're one of many. And your team members, they have different styles and preferences on how to write Markdown. So Markdown is a markup language, also like this page is generated by Markdown. But you can do this in many ways. You can, for example, indent with 2 or 4 spaces, also 3, also 6. And you can have images displayed that have a caption, yes or no. And there are many more things you can or cannot or do not need to do in Markdown. That's usually you have a lot of liberty how to write Markdown. But then you and your team want the repo to have a consistent coding standard anyways. So they all agree that you should have one coding style, one coding standard. But how would you do that? How would you enforce this? One option here again is to write a script. And this script, it will run probably your code. You have to start it manually and then will check using a linter. A linter is a tool that checks for style. And it will give you some errors. On those errors, you then will have to find out who caused it. I think that is fair, that you want the right team member to be identified, and then he or she can fix it. Again, here a GitHub action can do this more automatically, and you'll see this soon. The next question is, the next use case for GitHub Actions is, imagine you work on a free and open source software coding project. Your project, it uses a test suite to guarantee quality. So every bug you see, you make it into a test case, and then you fix the test, and then you're sure that there's one less bug. You also have users, and they submit code using a GitHub fork. So they fork your repository, then they give a pull request. It's the common way for externals to contribute to GitHub repositories. And you have a user that does that, submits code to your repository. You are worried that when you accept that code, you will suddenly have a bug in it. That means maybe this user did not write tests, and or maybe you're unsure if this user has even run the tests. And you want to make sure that it indeed passes all the tests. How would you do that? One solution is that you go to the fork, to the pull request. You can check out a specific pull request in GitHub and then run the test suite from there. So that means you need to download it on your computer or update your Git repository, whatever, and you need to run it by hand. And then you find if it worked, yes or no. Also here we have a clear use case for GitHub Actions, because it can do this more automatic. Good, so now I have a bit of an idea which the problems are that GitHub Action could help solve. The goal of this presentation is to understand what GitHub Actions is, why they are important, and we're going to practice to use them. I won't discuss best practices for GitHub Actions, and I'm not going to show and explain a complex setup. Instead, we will do some trivial, we will use some pre-programmed code. We'll be looking for a GitHub action that we want to use or may want to use. And it will show you a bit of literature here about what they can prevent, but I'm not going to use complex scripts here at all. Alright, so what are GitHub Actions? So here we have the logo of GitHub Actions, and this is the definition of GitHub Actions. It's a continuous integration service from GitHub that is free for free and open source software development. So a continuous integration service is a service, something that is done by others, on servers by others. And this service is a continuous integration service because it will be triggered every Git, on some Git actions. It allows you to continuously integrate new code with old code. And a continuous integration service, when you add new code, it will be triggered. In English, it allows you to run code triggered by a Git action, for example, Git push. So it is a script, and here we see a very minimal script. And if I upload the script to GitHub repository, and I will show this in a bit more detail, then it will be running, and I'll show you some screens. But this is how a GitHub action script looks like. It's just when to run. What it does, it runs a Python script after checking out the repository. And it does this every time someone does a git push to that repository. Which means it is run every time something new is added to the code. So you can continuously integrate new code with what's already there. Why are these things important? Well, first, what is important to know is that it's free for free and open source software development. What's more important is it helps assure quality of your repository. You can show that you care about quality. You can help collaborate with a team. It can give some rules as a team that you agree upon following. It helps you show you are a good team member. And it also helps interacting with your users. And also it shows that you care about your users. So from those use cases, how would you then use a GitHub action? Well, the easiest way to find those scripts is you're going to find a GitHub Actions script from someone else. That's all there is. It's just one file you need to copy. Sure, you need to modify it, but if someone has this working, yes, you will have it working too in most cases. You need to put this file in some kind of folder. This is the standard folder. .github, you really need a dot, and the subfolder workflows. If you put a GitHub Actions script, typically YAML scripts, they have to be YAML scripts, then you commit them, and then you can see the action unfold in the GitHub Actions tab. Also, you could just fork a repository, then you have the same scripts and it works exactly the same. What I'll be doing now, I will show you a general GitHub Actions script, and then I'll show you how it looks like, and then I go in a bit more details with examples. So here we have a general GitHub Actions script. And here I just go through the line. So it's called check something.yaml. So YAML is a file format. It's a markup language. YAML is short for yet another markup language. And it's a popular format. And this script, it's triggered. Here you specify the triggers. So that's what on colon means is, hey, this is the section where we're going to specify the triggers of the script, when the script will actually be run. This script will be run when someone pushes to the repository. There are more different triggers, but this is the general format. This is probably what you need most often. The jobs section are where you specify the jobs. An action script can do multiple jobs. In this script we only have one job, and that job is called check something. And this job runs on a virtual machine that runs the latest version of Ubuntu, where Ubuntu is a Linux distribution. What that job does is described in this steps section. So here below this you would run your script. So this is a minimal script, and I will show you some examples soon, but first I will show you how this looks like. So let's say you upload a script. How do you then view what they do? So it's in this section. So to find, so let's say you submit a script, then in the GitHub Action front page of your page, make it a bit bigger there. So this is the front page of a GitHub repository. You click on the Actions tab, and this will take you to the actions. So here is that same repository, and I've marked in red and blue a bit what it looks like. So red, these are the names of the 4 scripts. You see they are all in the .github/workflows folder. They're all YAML files. You don't see this for all. You don't see the complete paths, but we know that at least 1 and 2 of them have the YAML file extension. We see that there are 40 workflows being run, and here we see 3 results. And these 3 results are produced from 3 different scripts. Here we have check markdown, here we have check spelling, and here we have run code. So these are the 3 of the 4 scripts shown here. Here I highlight 3 of those scripts. They are triggered by the same commit. You can also see who pushed that commit, in this case me. And each of these things may break or pass. And in this case, this red cross means that it failed. So when you see that, you probably want to click on one of those actions. So for example, now I click on break code. That's the name of the commit. That has nothing to do which script is called. The script which you are investigating the results of is called check spelling here. So this is to check the spelling of this commit with the name, with the commit message break code. So when you click on that to see the action of check spelling, then you will show of this action all the jobs. This action called check spelling had only one job called check spelling. They have then in this case identical names. They don't need to have identical names, but here we have an action that has a job called check spelling. When you click on that, in that case you will be taken to the error log, usually automatically, so it will also scroll a bit down, and here we can see what it complains about. So it finds some misspelled words here. That is the whole purpose. Like spelling is spelled with an S, so this is a stupid spelling mistake. We can fix that. And now we know we need to fix this. So this is how you view error logs. And let's go into a bit more details on some examples of scripts that you can use. So my first example script, and this is a complete GitHub Action script, is to check if your links are broken. The triggers are the same. The job, there's only one job called check links running on Ubuntu, and there are two steps. The first step, you commonly find this as the first line, is that it uses a standardized GitHub action. So you don't need to write the code at all. It's a GitHub action that takes care of itself. You can find this GitHub action. It's called checkout. You can find what it does on GitHub. It's a shorthand for doing a lot of steps by hand yourself. In this case, this action checkout means it clones your repository on a virtual machine that has Ubuntu. It's called checkout. It's very common to see this as the first line of a GitHub Actions script. It uses version 4 of that script, so you can also, there's some versioning there. After that, it uses a GitHub action called like this, written by this person or this user or this organization. In this case it's a dude, I think. Version 1. And that's all there is. Then it starts running. For a spell checker, also here I use the Pi spelling action written by this GitHub user and this version. And another one, here we have a markdown style checker written by this organization or user, and this is the script he or she uses, and I can just use that, so it's not much work. All the rest is the same. A more general example would be to use run. So instead of uses, which means that you're going to use a GitHub action by someone else, you're going to run a bash command. And a bash command can also be that you use apt-get to install stuff, but it has some Python version installed. You can do ls, you can do whatever you want from there in bash. And this works as it is. It shows you the Python version, and it will run this Python script if it's there, and it will give an error if this Python script is not there. So this means with GitHub Actions you can run whatever you want, whenever you want. Good, with that out of the way, and there are some frequently asked questions that I will happily skip. I want to discuss some findings in the literature, what a continuous integration service, such as GitHub Action, what kind of effects they may have. So there's this study that finds that if you use a continuous integration service, bugs are exposed around 20 times faster. You can agree or disagree with my calculation here. New features are added around 4 times faster. Here's again my calculation. But what is commonly done, and I won't talk about this here, is that you can use GitHub Actions to run your test suites. If you run code, you can run tests, and that is what I also commonly use it for. We know that coding errors are extremely common and that simple testing can prevent most critical failures. So how common it? Yeah, it was in all the papers they used, but this paper it shows that indeed most errors are very easy to spot with continuous integration services. 100% of the catastrophic failures, I'll zoom in on this. So catastrophic failures are failures that are the most problematic. 100% would be exposed by using code coverage testing to find the error handling logic, or to go through the error handling logic, because this is where the errors were. After which you check that, after which you go through all the branches of the error handling logic, like going in or going out of it. For example, one common example is that people leave just a to-do, just in text or as a comment, or do nothing in the code that should handle the error. So that means they forget to implement what should happen, and that crashes the code. So simple testing, good idea. GitHub Actions can do this for you. Yeah, you can use it to measure code coverage. This is the percentage of code that is tested. And this correlates very strongly with code quality. A lot, I would say. Here we see some numbers. If you go from 62 to 92%, then more than twice as much faults are detected. Although in another study, we see that the correlation is in some cases very high, like close to 100%. Because code coverage is so important, some communities make 100% code coverage mandatory to pass if you do a code peer review. And obviously you can use GitHub Actions to check for coding styles such as Python's PEP8 and R's tidyverse style. Good, so that's the literature. Let's take a look at the exercise. So it's most useful to try out those things. Exercise 1 is to work with GitHub Actions, and for that I've prepared a repository that will ask you to fork, read the section how to view an error log, and then find the error message and fix all those errors. Exercise, let's take a look. So I can show you how it looks like. So I'm not going to fork this repository. You can actually, because I'm not going to fix it, but I'm going to show you where you can find the action. So that's here. Then you go to one of your favorite scripts. So I like to click on check spelling here. Then I need to click on the job. And here it takes me to the spelling errors. And I can see that in the file readme.md there's a misspelled word called spelling with a Z. And if I change this in readme.md, it will be changed. And I can show you if I go to the repository's front page. I click on readme, and I see that here on purpose I put a spelling error. And the GitHub action showed me out, pointed out this spelling error. So that's great, that's well done. Yeah, I can fix those errors, but I think it's obvious enough now. Exercise 2 is about finding a GitHub action. So let's say you want to do something yourself. Let's take, for example, a Python unit test framework. It doesn't matter. You serve to the GitHub Actions marketplace. I'm going to do this in a tab. So it's here already. See the word marketplace. We're going to find some GitHub action we want to do. And then we're going to copy paste it in a file. I'm not going to copy paste in a file, but I will show you where it is. So here we have the GitHub Actions, the marketplace with GitHub Actions. So only choose only actions here. And let's say I wanna. There are a lot of things. Like there's a lot of things here. There are even categories for all those things. What I'm gonna do is I'm gonna look for a Python unit test. Python unit test. Let's see how easy those things is. Or so here we have automated unit testing. You're not given test case. Alright, here we have using PyTest. It's one of I don't know which testing framework we'll pick this one. So PyTest is a Python testing framework. Let's assume I use that. Then here we see the action, and then here it's how to run it. There, this is all you need to do. Copy paste this and you're done. So I can add this line to a repository, to a script that's already existing, and I'm done. Like we see at the start of this script that it does need to check out the repository. It uses the checkout action, and then it runs the tests in this way. It also shows some, apparently there's some advanced examples too. I'm not going to look at that. I already know I should copy paste these two lines and I'm done. Finally, there's an access about the findings in the literature. I just went through it, and the question is, do you think GitHub Actions is worth it? And you can disagree with me or agree with me. I'm always happy to discuss the literature with you, and the references are here below in case you want to check me. With this, I hope I have shown you, let's go to the goals. I hope you now understand what GitHub Actions is, why it is important, and that you've been able to use GitHub Actions in your own GitHub repository. With this, I wish you a very good day. Bye!